Okay, let's go back to multivariable calculus. So let's go back. So we talked about inner product or dot product. And we talked about how we can use inner product to find the angle between vectors. And also how we can use inner product to find shadow or projection of one vector onto another one. Okay, these are two things we learned about the vectors. There are a lot of other different things we can do with inner product, but some interesting properties happen, they appear in three-dimensional space, which they don't appear in two-dimensional space. And that's related to existence of another product called cross product. Cross product is a type of product we can define in three-dimensional space. So if we have two vectors, u, which is u1, u2, and u3, a vector inside three-dimensional space. And if we have another vector, v1, v2, v3, we have a new vector, which is cross product of u and v. So before defining it, I should say one thing to note is that inner product or dot product of two vectors is a number. So if we have two vectors, if we look at their inner product, the final answer would be a number. Now the case about cross product is different. If we have two vectors, if we look at their cross product, the answer is another vector, is a third vector. So for example, it would be something like this. Their inner product is a third vector there. Okay, how can we compute that? Does anyone know, is there any, well, raise your hand if you are not familiar with matrices and determinants of a matrix. Okay, so in order to compute this product, we need to know a little bit about matrices and their determinants. Okay, so let's look at that. What is a matrix? A matrix is just a box of numbers. A matrix. So these are prerequisites to define cross product. A matrix is just, well, it's a movie, and also it's just a box of numbers. Well, it has other meanings too, but what does a box of numbers mean? It means, for example, something like this, a table of numbers. 3, 4, 2, -1, 0, 1, 2, 4, 3. Okay. This box of numbers, this matrix, it has 3 arrows. 3 rows, sorry. So I'm using arrows to show it has 3 rows, right? The first one is this one, 3, 4, 2. The second row is -1, 0, and 1. And the third row is 2, 4, and 3. It also has 3 columns, right? The first column is this one, 3, -1, 2. The second column is this one, 4, 0, 4. And the third one is this one, 2, 1, 3. Okay. Sometimes we might have a matrix which the number of rows and arrows are different, like this. 2, 1, minus 1, 2, 3, 3, 5, minus 2. This one has 4 rows. And 2 columns, right? Now, at this point, we are interested in the matrices which their number of rows is equal to the number of columns, like this one, or this one. Yeah, the answer to your question is yes, we would get to that. When I'm explaining how it's related to the linear algebra we were studying, I would explain that, yes. Someone asked if the number of rows is equal to the dimension of the space. That is correct. But now, at this moment, there are just box of numbers for us, just a box which has some numbers in it, right? So this thing has 2 rows and 2 columns. We call this a 2 by 2 matrix, right? This one has 3 rows and 3 columns. We call this 3 by 3 matrix. Okay. Now, to any matrix, we assign a real number. We call it determinant. Determinant. What is it? Well, let's start with 2 by 2 matrices. So in general, a 2 by 2 matrix is like A, B, C, D, right? A, B, C, and D, they are numbers. The determinant of this matrix is equal to A times D minus B times C. It's just a number. So let's say 3, 5, 2, 1. What is the determinant of this matrix? Is 3 times 1 minus 2 times 5. So we multiply these two, A and D, and then we subtract the multiplication of these two, C and B. Here 2 and 5. 3 times 1 is 3, 2 times 5 is 10. If we subtract, we would get minus 7. That would be the answer. That would be the determinant. Let's look at just one more example of this. Say, what is the determinant of minus 1, 3, 7, 2? Well, say minus 3. It would be minus 1 times 2, multiplication of these two, minus multiplication of these two, minus 3 and 7. So minus 1 times 2 is going to be negative 2, minus negative 3 times 7 is going to be minus 21, but we have minus 2 minus 21, which is 21 plus 21 minus 2, which is 19. That would be the determinant of this one. Adam, the answer to your question is also yes. I would mention that that's the reason the relationship between determinant, inner product, cross product, and volume and area is the reason I'm defining this notion. We would get to that. So here determinant is 19. That's how we compute the determinant of a 2 by 2 matrix. That's how it works. Okay, is there any question here about how we compute determinant of a 2 by 2 matrix? Okay, if no, let's move one step further. Let's look at the determinant of 3 by 3 matrices, something like this. 2, 1, 3, 5, minus 1, 1, 2, 1, 2. Okay. I want to compute the determinant of this one. The idea is that we should, there's some steps to solve this one. We should choose one, maybe, okay, I would, maybe I should show it on the matrix itself. We should choose one row and one column, okay? Choose one row and just one row. Let's start like that. Let's choose one row. We could choose one row or one column. I would choose this one. It doesn't matter. You can choose any row you want. You can choose any of the columns you want. I would choose this one, okay? Now, start from the first element of this row. This is 2, right? Look at the first element. Look at the column which contains this first element. That would be this column. Okay? Forget about this row and forget about this column. What remains? The remaining part is a 2 by 2 matrix. This is the remaining part, which is a 2 by 2 matrix. Compute the determinant of this remaining part. Okay, I know how to do that. Determinant of this remaining part is -1 times 2 minus 1 times 1, right? What is that? It's -2 minus 1, it's -3. The determinant is equal to -3. Okay, now look at this number we had here in this intersection, in this number in the intersection of this row and this column. It's 2. Multiply 2 by -3. Okay, we have a number. Also, I would write positive above this number 2. I would write negative on the number next to it. I would write positive above the number next to that. Plus, minus, plus. That's just the rule. Let's fix that. I would write plus, minus, plus. Okay? I would get that number. So let's now forget about this column we chose. Let's just forget about that. And we had this row. Okay. So that was the computation related to 2. Now we should move on to the next number in this row, which is 1. Look at the column which has this number. This is that column. Now, if we remove this row and if we remove this column, 4 numbers remain. Look at the remaining part. The remaining part is 5, 1, 2, and 2. 5, 1, 2, and 2. Compute the determinant of this matrix. Well, I know how to compute the determinant of that. It would be 5 times 2 minus 1 times 2. It would be 10 minus 2, it's 8, right? It would be 8. Multiply 8 by the number which is here in the intersection of this row and this column, which is 1. And because above this one there is a minus, just add a minus here next to this multiplication. That would be the computation for the second column. Okay, let's erase these things. Now, in this row, we did the computations for the first element. We did the computations for the second element. Now we can do the computations for the third element. Look at the row which has the third element. If I remove this column, this red column and this this red row and this blue column, the remaining part is a 2 by 2 matrix. I can compute the determinant of this 2 by 2 matrix. It would be 5 times 1 minus 2 times minus 1, which is 5 minus minus 2, which is 5 plus 2, that's 7. Look at the multiplication of 7 with this number here in the intersection of these two rows, this row and this column. And because above 7 we have positive here, we put positive. Above 2 here we had positive, we put positive here. Okay, let's compute these numbers. 2 times minus 3 is minus 6. 8 times 1 is 8. There's negative sign there. It would be minus 8. 3 times 7 is 21. What is that? 6 and 8 is 14. It would be 21 minus 14. It's 7. Determinant of this 3 by 3 matrix is 7. I would solve another example. So find the determinant of the following matrix. So let's say we have 2, minus 1, 1, 3, 0, 2, minus 1, 1, 3. Well, the answer is 7. If I've done the computations correctly, after we do these things, and when we add these plus and minus signs, we do multiplication, we add everything together, we get to 7. The determinant of that matrix would be 7. Okay. Yeah, sometimes I'm replying the private questions. So if you don't see any message, but I'm explaining something to someone, that's the reason. Okay. So again, we can choose any row or column. We start with the first row because if we choose another row, it would be slightly different. I would explain that, but let's, for the moment, let's only choose the first row. Okay, we start with the first element. Consider the column which has the first element. It would be the blue column. Look at the remaining parts. It would be 0, 2, 1, 3. Compute the determinant of the remaining part. It would be 0 times 3 minus 2 times 1. It would be 0 minus 2. It would be minus 2. Okay. So we should multiply this number minus 2 by this number in the intersection, which is 2. Again, above these numbers, I would write plus, minus, plus. So this is plus 2 times minus 2. Now, let's erase the first column. Let's look at the second column. Look at the remaining matrix. If I remove this row and if I remove this column, what remains is 3, 2, minus 1, 3. The determinant of this matrix is 3 times 3 minus 2 times minus 1, which is 9, minus minus 2 plus 2, 11. Now I should multiply 11 by this number here in the intersection of this row and this column. That number is minus 1, but there is a minus above it. We should write that minus here too. If you can't see where I'm writing, maybe I can erase the question. And maybe depending on the device you have, the thing you see is slightly different. So first we had plus 2 times minus 2. Then we had 11 times the number in this intersection, which is minus 1. But we should add a minus because we have minus here above minus 1. Okay, erase this column. Let's look at the third element, the last element in this row. If I remove this row and this column, what remains is this 2 by 2 matrix. I need to compute the determinant of that. That's 3 times 1 minus 0 times minus 1, which is just 3. I should multiply 3 by this number in the intersection. And I would have plus here because I have plus above it. What do we get? Minus 4 plus 11 plus 3, it's 10. Okay, someone already got to the answer. That is correct. The determinant of this matrix is 10. Okay, so maybe it's good for you to just do one example yourself. Find the determinant of this matrix. Okay, think about it for 2 minutes, compute that, and then tell me what is the answer. Okay, let me also compute that. So I would start the first row, and I would write plus, minus, plus. I would start with the first column. I would compute the determinant of the remaining part. It's 2 times 3 minus 1 times 3. It is 6 minus 3. This is 3. The number in the intersection is 3. I would multiply 3 by 3 with plus. Okay, that would be the first column. Now I would look at the second column. The remaining part is 1, 3, 2, 3. The determinant would be 1 times 3, these two numbers, minus 3 times 2, which is 3 minus 6, it's minus 3. I would multiply minus 3 by this number in the intersection, which is 2, with the negative sign, because there's negative sign above it. Okay. Now, let's go to the third column. The remaining part is 1, 2, 2, 1. The determinant would be 1 times 1 minus 2 times 2 would be 1 minus 4, it's minus 3. So we have minus 3 times the number in the intersection, which is 1. This sum is equal to 9 minus minus 6 plus 6 minus 3. 6 minus 3 is 3, 9 plus 3 is 12. Now, if you don't see, the answer is 12. So that would be the way to compute the determinant of the 3 by 3 matrix. We can compute the determinant of 4 by 4 or even in higher dimensions, and it's quite similar, but we don't need that for now. 2 by 2 and 3 by 3 are the things we would use mostly. Okay.
Wait, I have a question.
Yes, sure.
Sorry, so what was the final answer for the last one?
Let's go back. Oh, no, not this one. It's 12.
So you do 3 times 3, which is 9, right? And then you do -2 times -3, which is 6. And then you do -3 times 1, which is -3. And then you just add those all together?
Exactly. Yeah.
Okay.
Yeah. Yeah, that's how we compute the determinant of 3 by 3 matrices. That is correct. Okay. So now we can use that. We can use what we saw about determinants to compute cross product. How is that? Well, first, remember in R3, in three-dimensional space, we had these vectors I, j, k, right? I was equal to the vector 1, 0, 0. J was equal to the vector 0, 1, 0. K was equal to the vector 0, 0, 1. That's the definition of these three vectors. Suppose you have two vectors and you want to compute their cross product. Say 2, -1, 3, and the other one say 1, 0, -2. I want to see what is U cross product V. That's the question. How can I compute that? Okay, the answer is, well, maybe it would be better if I go to another page. So U is and V is this. Okay. We define the cross product to be, okay, look at this matrix. It looks like cheating a little bit, and it is, but it's okay. Right now, so we have a matrix with 3 rows. In the second row, write down the coordinates of U. 2, -1, 3. In the third row, write down the coordinates of V. 1, 0, -2. I would explain that. Let's first, yeah, you're completely right. I will explain what is cross product on the graph and how does it geometrically look like. First, learn how to compute it, okay? And then we would see what does it refer to. We might not to get to that part actually today, but we definitely talk about it. That's an important part. So in order to complete this matrix, I should choose something for the first row. Just write I, J, K here. Well, you might say I, J, K, they're not numbers. Matrix was supposed to be a box of numbers. I know that. It's kind of cheating. But just do that. Write down I, J, K there. You would get a 3 by 3 matrix. Compute determinant of that matrix. Well, what does that mean? When we are computing determinant, we should choose one row. First row here, I would do that, okay. And then I should choose a column, first column. And then I would write plus, minus, plus here, yeah. Okay, I should compute the determinant of the remaining part. The determinant of remaining part is -1 times -2, -3 times 0. The answer is 2. Then I should multiply 2 by the number here in the intersection. What is the number in the intersection? It's I. Just write 2I. Just write I there. It's not a number, but just write it there. It's just like there was a number there. We would multiply this determinant by this number here. We just do the same thing here. Okay, erase the first column. Look at the second column. If I remove this row and this column, what remains is this 2 by 2 matrix, 2, 3, 1, -2. Compute the determinant of that. It's 2 times -2 -3 times 1, which is equal to -4 -3, it's -7. Okay, I should multiply -7 by the number here in the intersection. That's J, just write J there. Also, because above J there is minus sign, put minus sign here. Okay, now erase this column. Let's go towards the third column, the last column. If we remove this row and this column, we would get a 2 by 2 matrix. What is the determinant of that? 2 times 0 -1 times -1. 2 times 0 is 0, -1 times 1 is -1, -1 is 1. Okay, we should multiply 1 by the number in the intersection, which is K. Okay. So what is the answer? The answer is 2i plus 7j plus k. What does it mean? Just write these numbers next to each other. 2, 7, k. Sorry, 1. 1 times k, 1. We would write these numbers as coordinates. K is just 1 times k, right? We don't write 1. K is the coefficient of k is 1. We just write 2, 7, and 1 here. We would get a vector, a new vector. That vector is the cross product of the two vectors we started with. So we started with 2 vector. That's how we can compute the inner product. Let's do just one more example to make sure we understand what we are doing.
I have a question.
Yeah.
So what does the cross product represent? Like, what is it?
Yeah, okay. Someone else also asked this question. It is the second topic we would get to. I definitely would talk about that more carefully, but just give you an idea. So it is something which we will talk on the next Tuesday, but just in order to give you an idea, if you have U and if you have V, two vectors, there is always a vector which is normal to both of them, something like this. This vector is actually their cross product. It's orthogonal to these two vectors, and its length is equal to length of U times length of V. This time, rather than cosine of the angle between U and V, it's sine of the angle between U and V. It might look a little strange. I would explain what it means. Let's postpone that on Tuesday, because if I start to explain it a little bit, you get more confused. So let's today first just learn how to compute that. Okay, so we would come back to this problem.
Okay, so, thank you.
Yeah, you're welcome. So let's look at one more example. Let's say U is this vector. This is U. U is 2, 0, 0. Let's say V is this other vector. It's 0, 2, 0. Okay, this is U, 0, 1, 2. This is V. And we want to find the cross product of U with V. So we should construct a 3 by 3 matrix. The first row is I, J, K. Then we should write the coordinates of U here, and then the coordinates of V. So first we should remove this row and this column, compute the determinant of the remaining part. You can see it's 0, right? It's 0. If you can't see there, I would erase these things to write them there. It would be 0 times 0 minus 2 times 0, which is 0. Then it would be 0 times the number in the intersection, which is I. We should look at the second column. The determinant of the remaining part is 2 times 0 minus 0 times 0. That's also 0. So it would be J times 0 with minus. And then we should look at the last column. The determinant of the remaining part is 2 times 2 minus 0 times 0. It's 4. So it would be plus 4. The letter in the intersection is K. So it would be 4K, because 0 times anything is 0. 0 times I is 0. 0 times J is 0. What remains is 4K. What is 4K? Remember, K was this vector, 0, 0, 1. That was K, right? So it would be 0, 0, 4. What is this vector here? 0, 0, 4 is this vector. Okay, so inner product of U and V is this new vector. Okay, now the interesting thing is that, okay, let me see, there's a question. We already have an idea about how two lines cross each other in R2, like that. And we're finding the cross product of two vectors that makes them crossing. No, that is not true, but that's a good question. So we have an idea on now how to compute cross product, but the question is, what does that mean? What is the cross product? What does that mean? Right? That's a good question. I want you to think about that. Well, we have, you don't need to really search, but it's a good exercise for Tuesday. So for the next meeting, think about what does cross product mean. And then on Tuesday, we would continue cross product, and then we would understand what it means. It is related to right-hand rule. That is also correct. So we know how to compute it. We know how to compute it, but we still don't know what it really means, right? Okay, so let's postpone that to Tuesday. Any question now about how to compute cross product? And yes, the question is, so we put the vectors horizontally to fit them in 3 by 3 matrix. The answer is yes. We write the first vector in the second row, and we write the second vector in the third. That is correct. Okay, I think that's it for today. If there is no more question. Are we going to have homework for next week? Yes, I'm going to upload some questions for next Thursday. The answer is yes. Yep, goodbye everyone. Thank you and bye.